Now, we've already seen one type of radiotherapy, and we can refer to that as teletherapy, where the source of radiation is placed a long distance from the tumour or from the patient, and the patient is effectively irradiated from outside in. Now, that is one major type of radiotherapy. However, there is a second type of radiotherapy which dates from about the early part of the 20th century, and that is referred to as brachytherapy. Now, brachytherapy differs in concept entirely from teletherapy. Whereas teletherapy irradiates the patient from outside in, brachytherapy irradiates the patient from inside out. Very basically, we place a source of radiation, whatever that source may be, either close to, alongside, or actually inside the tumour tissue. And that can be used for a number of various sites. Now, the most common type of site, however, is for treatment of the uterine cervix. Now, this is a typical brachytherapy treatment machine, and there are certain features of this which differ from the teletherapy machine, which I think it's important to see. And the very first thing is, and probably the most important thing is, that it contains a live source. And here we have a dummy, a high dose rate iridium source, and you'll notice that it's a very, very small source attached to a cable. Now, there are a number of different isotopes which may be used in brachytherapy, but iridium-192 is used in this type of machine. Now, the source is stored inside the safe of this unit. There is a cable, and whenever we want to treat the patient, the buttons are pressed at the treatment console, and the source travels out by cable and sits in the applicators which are already in the patient. Now, this, as I say, is a gynae setup for treatment of gynecological cancers, and this particular set of applicators is used to treat the uterine cervix, which is by far the most common application of brachytherapy. However, there are variations to this. Some of these applicators have extra shielding in certain parts to protect vital organs. We can also use an applicator to treat the vagina alone, but the principle remains the same in that we use a high dose rate source which is transferred from its safe down transfer tubes which sit in the applicators which have previously been inserted into the patient. Now, we can move away from the gynecological application and use this for other sites in the body. And a very typical example might be treatment of the breast. And here we have a dummy breast showing the setup. Basically here, the breast is compressed using this template arrangement. Needles are inserted into the tumour tissue. These needles are then connected via transfer tubes to the selectron, to the machine. And again, the principle is that a high dose rate source is sent down the transfer tubes and sits inside the needles for as long as is required to treat the tumour. There are three types of brachytherapy. The first type of brachytherapy is where you introduce the source literally alongside the tumour tissue or the tissue which you're trying to irradiate. That is called, broadly speaking, mold brachytherapy, and is the original type of brachytherapy. The second type of brachytherapy is where you introduce the source of radiation into the tumour tissue itself, and that is called implant or interstitial brachytherapy. And the third type of brachytherapy is where you introduce the source of radiation into a body cavity or into a lumen within the body. For intracavitary gynae brachytherapy, for treatment very particularly of the cervix, the empty applicators are first inserted into the patient. So we have an applicator going into the uterus of the patient, and we have two applicators going into the lateral fornices of the vagina of the patient. Now, the applicators themselves are hollow, non-radioactive tubes, and once they're deemed to be in a satisfactory position, then we can introduce the live source of radiation.
Okay, nice and still there. What we have to do now is just connect everything up to this machine.
So the applicators are first inserted into the patient. The patient is taken into the treatment room and connected up to the brachytherapy unit by the use of transfer tubes.
That's it, we're all done. So we're just going to pop outside now and start the treatment, okay?
And once the patient is connected up to the treatment unit, the radiographers go outside the room. Various checks are made on the time that this source of radiation has to be out of the safe in the treatment unit and inside the applicators, which are inside the patient.
Medium over is 62. Okay, so today we've got a source strength of 2.8038.
Yep, that's good.
Okay.
And once those checks have been made, buttons are pushed and the source travels from the safe inside the unit down the transfer tubes and into the applicators which are inside the patient. At no time does the source come out of the applicators and be physically in the patient. They're always inside the applicators which are in the patient. The advantage of brachytherapy is that when the source of radiation is placed inside the tumour tissue, you are limiting your dose to a very confined volume of tissue and you're sparing healthy tissue. The disadvantage of teletherapy is that although you're going to hit the tumour when you irradiate from outside in, you are actually irradiating through healthy tissue, and radiation can have effects on healthy tissue, as well as having the desired effect on malignant tissue. So brachytherapy has a very distinct advantage over teletherapy, and that is a very confined dose.